Somewhere online right now, a headline is claiming that new images from the Cassini spacecraft just shocked scientists, as if this happened minutes ago, as if the world is only now reacting to something brand new. Here's the uncomfortable twist. Cassini has not sent back a single image in years. The spacecraft that captured those final photographs burned up in Saturn's atmosphere back in September of 2017, deliberately, on purpose, by design, and every one of those final images has been sitting in public archives ever since, available for anyone to examine. No new shock happened 3 minutes ago, but the actual story, the one buried underneath that fake urgency, is stranger, sadder, and considerably more important than any headline claiming a fresh discovery ever managed to be. This is the real story of Cassini's final images, why NASA chose to destroy a fully functioning $13 billion spacecraft on purpose, and why scientists are still, years later, working through what those last frames actually revealed about Saturn. To understand why those final images matter at all, you have to understand just how long Cassini had already been flying by the time it took them. The spacecraft launched from Earth in October of 1997, riding a Titan IV rocket into space during a decade, when most people were still using dial-up internet to get online. It took nearly 7 years just to reach Saturn, looping past Venus twice, then Earth, then Jupiter, using each planet's gravity like a slingshot to build up enough speed to survive the journey to the outer solar system. By the time Cassini finally slipped into orbit around Saturn on July 1, 2004, the mission had already outlived several of the computers originally used to help design it. Cassini was never supposed to last as long as it did. The original mission plan called for 4 years of observation, a single tour of Saturn, its rings, and its moons, before the spacecraft would run out of fuel and NASA would call it finished. Instead, Cassini kept working. 4 years became a second mission, extended into 2010. That became a third. Mission stretched all the way out to 2017, 13 years in total, more than 3 times longer than anyone originally planned. Over that span, the spacecraft circled Saturn 294 times, sent back more than 453,000 images, and helped rewrite entire chapters of what scientists thought they knew about the outer solar system. And that's exactly what made the ending so difficult for the people running the mission. By 2017, Cassini's fuel tank was finally running dry, and engineers back on Earth faced a genuinely uncomfortable decision. The spacecraft still had working cameras, working instruments, and a functioning radio link back to Earth. In theory, it could have simply kept drifting near Saturn, silent and useless, for years or even decades after its fuel ran out, tumbling in an unpredictable orbit with nobody controlling where it went. That possibility is exactly what worried scientists the most, because Saturn isn't just a planet with pretty rings. It's a planet with moons, and 2 of those moons, Enceladus and Titan, are considered among the most promising places in the entire solar system to search for the ingredients of life. Enceladus has a subsurface ocean of liquid water spraying out through cracks in its icy shell. Titan has lakes and rivers, not of water, but of liquid methane and ethane, along with a thick atmosphere full of complex organic chemistry. If Cassini, coated in whatever microbial hitchhikers might have survived the trip from Earth 2 decades earlier, ever drifted into one of those moons and crashed there uncontrolled, it could have contaminated the very environments scientists most wanted to study for signs of life, corrupting any future search before it even had a chance to begin. So NASA made a deliberate choice. Rather than risk that outcome, mission planners decided to end Cassini's story on their own terms, guiding the spacecraft into a series of increasingly daring maneuvers that would culminate in its own destruction, and in doing so, guarantee it could never threaten those moons at all. That final chapter earned its own name, the grand finale. Beginning in April of 2017, engineers steered Cassini into a set of orbits nobody had ever attempted before, threading the spacecraft through the narrow, roughly 2,000-kilometer gap between Saturn's cloud tops and the innermost edge of its rings, a region so uncertain that some scientists worried debris in that gap could destroy the spacecraft on the very first pass. It didn't. Cassini threaded that needle 22 times over the following months, gathering data no spacecraft had ever collected from that close, measuring Saturn's gravity and magnetic field with a precision only possible by flying directly through the space separating the planet from its own rings. Then, on September 15, 2017, Cassini made its final approach, and this time there was no plan to survive it. Mission controllers at NASA's Jet Propulsion Laboratory pointed the spacecraft's antenna toward Earth one last time and set its cameras to keep capturing images for as long as physically possible, right up until the atmosphere took over. Cassini began its final descent at roughly 113,000 kilometers per hour, plunging directly into Saturn's upper atmosphere at an angle engineers had calculated months in advance. As it fell, the spacecraft's thrusters fired continuously, fighting to keep its antenna pointed at Earth so its instruments could keep transmitting data for as long as the signal held. turning Cassini's own destruction into one final active science experiment, rather than a passive freefall into silence. The images Cassini sent back during those last hours are what people mean when they talk about its final images, and they are genuinely remarkable, not because of some hidden shock buried inside them, but because of what they quietly, plainly showed. The last complete image Cassini ever captured and fully transmitted back to Earth shows the spot. On Saturn, where the spacecraft itself was about to plunge in, a swirling, turbulent patch of clouds near the planet's north pole, captured just hours before Cassini became part of the very atmosphere it was photographing. There is something genuinely strange about that image once you sit with it. A spacecraft photographing its own grave, hours before arriving there at a resolution. And proximity nothing built by humans had ever achieved before or has achieved since. Alongside that final, full image, Cassini managed to transmit partial data for several more frames. As its signal began degrading, fragments of images that never fully completed cut off mid-transmission as the spacecraft's instruments finally lost their fight. Against Saturn's atmosphere, those broken incomplete frames carry their own kind of weight, less because of what they show and more because of what they represent. The literal last moments of an active transmission before contact was lost forever. At 7:55 a.m. Eastern Time, when Cassini's signal simply stopped arriving, exactly as engineers had calculated it would. But the true value of Cassini's final images isn't really about a single shocking photograph. It's about the years of build-up and analysis that surrounded them, and what scientists were able to piece together from the grand finale as a whole, once they had time to properly study everything the spacecraft sent back during its final months. During those last close orbits, threading the gap between Saturn and its rings, Cassini's instruments picked up something researchers hadn't fully expected. Direct evidence of Saturn's rings actively raining material down into the planet itself. Instruments designed to measure dust and charged particles detected a steady stream of ring material falling into Saturn's atmosphere, a process scientists had long suspected existed in theory, but had never directly measured this close to the source. That discovery matters for a very specific reason. It means Saturn's rings are not the eternal, unchanging structure many people casually imagine when they picture them. They are actively eroding, raining down into the planet at a rate that, if it has remained roughly consistent, suggests the rings might only survive for another few hundred million years before they largely disappear. On a human timescale, that sounds essentially permanent. On an astronomical timescale, it means Saturn's rings could be a relatively temporary, comparatively recent feature of the solar system, and that humanity may have been lucky enough to exist during the specific narrow window when they happen to still be visible at all. Cassini's final dive also let scientists measure something that had eluded them for the entire 13 years of the mission before that point. The exact length of a single day on Saturn. That sounds like it should have been simple to figure out decades earlier, but Saturn's thick, featureless atmosphere and its powerful shifting magnetic field had made a precise measurement stubbornly difficult, with earlier estimates from the Voyager missions in the 1980s disagreeing with Cassini's own earlier data by several minutes. By diving directly through the gap between the rings and the planet, close enough to sense subtle variations in Saturn's gravitational field caused by material sloshing around deep inside the planet, Cassini finally allowed scientists to pin the number down with real confidence. 10 hours, 33 minutes, and 38 seconds. A figure that took 13 years of orbiting and one final deliberate plunge to actually confirm. And then there's Enceladus, the moon that arguably justified the entire risky, dramatic ending on its own. Years before its final plunge, Cassini had already flown directly through plumes of water vapor and ice erupting from cracks near Enceladus's south pole, sampling that spray directly with its onboard instruments the way a plane might fly through a cloud. What it found inside that plume was extraordinary. Water, organic compounds, and molecular hydrogen, a combination that, on Earth, is strongly associated with hydrothermal vents on the ocean floor, the same kind of vents some scientists believe may have hosted the earliest life to ever exist on our own planet. That discovery, more than any single image from the grand finale itself, is the real reason NASA refused to let Cassini's story end with an uncontrolled crash. A moon with a subsurface ocean, organic chemistry, and a potential energy source for life was simply too scientifically important to risk contaminating. And that risk is precisely what drove mission planners to choose a controlled, fiery ending inside Saturn itself over any alternative. It's worth sitting with the irony baked into that decision for a moment. The safest possible way to protect a place that might harbor alien life turned out to be destroying, completely and deliberately, the very spacecraft responsible for discovering it might be there in the first place. Enceladus wasn't the only place Cassini quietly rewrote the record books either. In January of 2005, Cassini released a smaller companion probe named Huygens, built by the European Space Agency, and sent it parachuting down through the thick orange haze covering Saturn's largest moon, Titan. It remains to this day the only spacecraft ever to successfully land on a world in the outer solar system. What Huygens found on the way down, and after it touched the surface, was a landscape that looked almost unsettlingly familiar, and completely alien at the same time. River channels carved into the dried lake beds, all the geological signatures of a world shaped by flowing liquid, except the liquid in question was never water. Titan's surface temperature sits at roughly minus 179 degrees Celsius, cold enough that water ice behaves like solid rock, and the liquid actually filling Titan's lakes and rivers turned out to be methane and ethane, hydrocarbons that exist as gas here on Earth but pool into lakes on Titan's frozen surface. Cassini spent the following years mapping those lakes from orbit using radar that could see straight through Titan's thick atmospheric haze, eventually confirming an entire hydrological cycle running on hydrocarbons instead of water, complete with rain, rivers, lakes, and evaporation, an alien mirror of Earth's own water cycle running on completely different chemistry, tucked inside our own solar system the entire time. Cassini also spent years quietly documenting one of the strangest weather phenomena ever observed on any planet, a massive six-sided storm sitting directly over Saturn's North Pole, roughly 30,000 kilometers across, wide enough to fit 4 Earths inside its own outline, with walls of clouds racing along its hexagonal edges at speeds exceeding 320 kilometers per hour. Nobody fully agrees on why that hexagon holds its shape instead of collapsing into a normal circular storm the way hurricanes do here on Earth. And laboratory attempts to recreate similar hexagonal patterns using rotating fluids have only partially reproduced the effect. Cassini watched that storm persist, essentially unchanged in shape, for the entire 13 years of the mission, long enough to observe it shift color as Saturn's decades-long season slowly turned from winter toward summer at the planet's pole, a shift in Saturn's atmospheric chemistry that no earlier, shorter mission could ever have possibly caught. Not every scientist involved with Cassini agrees on how much more the mission's final data still has left to reveal, and that disagreement is worth taking seriously rather than glossing over. Some researchers argue the grand finale's gravity and magnetic field measurements still haven't been fully explained, particularly the persistent mystery of why Saturn's magnetic field appears almost perfectly aligned with its rotational axis, a puzzle that, according to the physics currently used to explain how planetary magnetic fields are generated, shouldn't really be possible at all. Under the leading theoretical models, a planet's magnetic field needs to be slightly tilted relative to its spin in order to keep regenerating itself, and Saturn's field appears tilted by less than 1/10 of a degree, an alignment so close to perfect that some scientists argue it hints at something happening deep inside the planet that current models simply don't account for yet. Other researchers push back on how much weight to put on that anomaly, arguing that Cassini's data, while extraordinary, was gathered over too short a final window to fully resolve a question that fundamental, and that firmer answers will have to wait for a future mission specifically designed to probe Saturn's deep interior, a mission that, as of today, doesn't yet exist and isn't currently funded. There is also ongoing disagreement over what exactly is happening deep inside Saturn to keep that magnetic field so unnaturally aligned in the first place. One leading idea suggests that layers of helium rain, falling slowly through Saturn's deep hydrogen atmosphere under crushing pressure, might be smoothing out the field in a way no other gas giant experiences in quite the same manner, effectively acting like an internal buffer that irons out the tilt other planets' magnetic fields normally carry. That explanation remains unconfirmed, built largely on models rather than direct measurement, and testing it properly would require an entirely new mission carrying instruments capable of probing Saturn's atmosphere far deeper than Cassini's own instruments ever could. Until a mission like that actually happens, the question stays open, one more loose thread hanging off a spacecraft that stopped transmitting years ago. That disagreement matters because it means Cassini's story, in a very real sense, still isn't finished, even though the spacecraft itself has been gone for years. Scientists are still publishing new papers built on data. The spacecraft gathered during its final orbits, still arguing over what some of those measurements actually mean, still mining nearly 500,000 images and years of instrument readings for details nobody has had time to fully examine yet. In that sense, calling those final images final is almost misleading. The pictures themselves stopped arriving in September of 2017. The process of actually understanding what they showed is, in a meaningful sense, still ongoing. There is a particular kind of loneliness built into the way Cassini's mission actually ended. Oh, if you're willing to sit with it. Every image the spacecraft ever sent back, all 453,000 of them, traveled roughly 1.4 billion kilometers across empty space to reach Earth. A journey that, even moving at the speed of light, took well over an hour one way. That means by the time engineers on Earth watched Cassini's very last transmitted frame arrive, confirming the spacecraft had survived long enough to send it, Cassini itself had already been gone for more than an hour, already torn apart and vaporized somewhere in Saturn's upper atmosphere, its own destruction complete before the news of its final success had even finished crossing the gap between the two worlds. Nobody on Earth was watching Cassini die in real time. They were watching a message from a spacecraft that, by the moment the message actually arrived, no longer existed at all. And unlike 3I Atlas or any interstellar visitor passing through on its own one-way trip, Cassini's ending wasn't something that simply happened to it. It was something humanity chose, deliberately, years in advance, weighing the value of a few more months of data against the risk of contaminating a moon that might already harbor the ingredients for life somewhere in its hidden ocean. That choice says something worth noticing about how the people running that mission thought about what they'd found. They cared enough about the possibility of life on Enceladus, a place nobody has ever visited, a place still years or decades away from any dedicated life detection mission, that they were willing to destroy the very spacecraft that discovered it, on purpose, rather than risk getting in its way. Inside mission control at the Jet Propulsion Laboratory, on the morning the signal finally stopped, the room was full of scientists and engineers who had spent the better part of 2 decades of their working lives on this single spacecraft. Some of them had joined the Cassini team fresh out of graduate school in the 1990s, and were now watching their own children old enough to understand what was happening. Footage from that morning shows people who study planets for a living, people trained to stay clinical and precise in front of data, visibly fighting to hold themselves together as the signal thinned out and disappeared. It is a strange kind of grief, mourning a machine. But it makes a certain sense once you consider what Cassini actually was to the people who built it and flew it. For 13 years, it had been humanity's only pair of eyes at Saturn. The only way anyone on Earth could see what was happening around that planet in anything close to real time. Losing it meant losing that connection entirely, with nothing scheduled to replace it for years to come. That absence is still ongoing today. There is currently no spacecraft anywhere near Saturn, and there won't be one again until NASA's Dragonfly mission, a nuclear-powered drone designed to fly through Titan's thick atmosphere and hop between locations on its surface, is expected to arrive sometime in the late 2030s. Between Cassini's final plunge in 2017 and Dragonfly's eventual arrival, an entire generation of scientists is growing up studying Saturn exclusively through archived data, images captured years before they ever entered the field, working with a dataset that will not grow by a single new frame until a new spacecraft finally gets there. Every question Cassini's final images left unanswered will simply have to wait. So here's the real question worth sitting with, once the fake 3 minutes ago urgency gets cleared away and only the actual verified science is left standing. Cassini spent 13 years teaching humanity more about Saturn than the previous 3.5 centuries of telescope observation combined, and its very last act, the thing it was doing in the moments before it stopped existing, was still gathering new data, still transmitting, still working, right up until the atmosphere it was falling into finally took the signal away for good. Somewhere out past Saturn's rings, the moon Enceladus is still there right now, its plumes, still spraying water and organic chemistry out into space exactly as they were the day Cassini first flew through them. Whatever answer is eventually waiting inside that ocean, life or nothing, or something in between that doesn't fit neatly into either category, humanity chose deliberately to protect the chance of finding out, even if it meant losing the one spacecraft that found the question in the first place,